What's up, guys? We're going to be jumping into 4.7 here. I'm splitting this one into 2 days, so this is 4.7a. It's really, really critical that you take good notes on this because this is going to be one of those things that's confusing, and if you don't have the notes in front of you, you'll probably forget how to do a lot of it. So make sure that you are copying this down well. Here's a couple vocab words. Pause and copy these down. It says a sequence is an ordered list of numbers that often form a pattern. Each number in the list is called a term of a sequence. We'll look at a couple examples of that, but beforehand, here's a funny cartoon. He's a good boy. Not you. All right, extending sequence says describe a pattern in each sequence. What are the next two terms of each sequence? Well, on this one, it goes from 5 to 8, 8 to 11, 11 to 4. Okay, so I see it here. It is plus 3. Every time. So this is what a sequence is. Each one of these things are called a term. So if I were to extend this and add 3, my next term would be 17, and I could do that again and add 3, and then my next term would be 20. Down here I have 2.5, 5, 10, and 20. So on this one it looks like it's doubling every time. So my term is by multiplying by 2. So my next two terms are going to be multiplying by 2. So I'd have 40, multiply by 2 again, and it's 80. I know you're thinking, wow, you said this one's a tough one. This is really easy. You're right. This part's really, really easy. But the next thing that we're going to be working on is how do we describe these things, and eventually these. Today we're focusing on this. How do we describe these mathematically? Here's a couple for you to try, so go ahead and pause and give those a go. The answer will be up in 3, 2, 1. There are your answers. You're adding 6 on this, and then 29 and 35. And then here, I wrote multiplying by half. You could have said divide by 2. I prefer multiplying, but again, I want to count that wrong. 25 and then 12 and a half for the answer there. All right, let's take a look at this. Arithmetic sequences, it says the difference between consecutive terms is constant. This difference is called the common difference. So in those examples we were just looking at, the value that's added over and over again is called a common difference. It says tell whether a sequence is arithmetic. If it is, what is the common difference? So I look for something that's happening every time. So that's plus 5. This is plus 5. And this is plus 5. There is a common difference between all these values of 5. So I'd say arithmetic with a common difference of 5. Down here, let's see, I'm looking for a consistent pattern. So that looks like plus 3. This is a plus 4. And then that's plus 4. So these have to all be exactly the same. So this one is not arithmetic. So you don't have to identify a common difference. That's all we're looking at on this. A recursive formula. Write this down. A recursive formula is a function rule that relates each term of a sequence after the first. The key word here is to the ones before it. Okay, a recursive formula, in order to use it, you have to know the value of the preceding term, or the one that came before it. Okay, so how to write a recursive formula for the arithmetic sequence. What is the value of the 8th term? Okay, so this is where you really need to pay attention, make sure you're writing good stuff down. First thing is to identify that common difference. So on this, the common difference is 7. Now the way that this is going to work, or 70, sorry, I don't know why I said 7, but I did. The way that this is going to work is that you start with that initial value. So the initial value we would say is the first value. That's the second. That's the third. And that's the fourth. So it says what is the 8th term? First term, second term, third term, and so on. So I would say that A, in function notation, the first term is 70. The way I would find term 2 is I would take term 1 and I would add 7 to it, which equals 70 plus 7, so that my second term is 77. So second term is 77. The way I would find the third term is I would take term 2 and I would add 7 to that, which would be 77 plus 7, which equals 84, and then this would continue. So what we need to do is come up with a way to write this out in a generalization. Okay, but let's go ahead and write out this particular answer. So the recursive formula is going to be A of n equals A of n equals A of the preceding term. So notice here, to find A of 2, I needed A of 1. To find A of 3, I needed A of 2. To find A of 4, I need A of 3. So I'm going to say it's n minus, n is the number of terms, n minus 1, the term that came before it. That's what that means. Plus my common difference, which in this case is 7. And then I would have to say with an initial value, or we don't need to write that. We'll just say when where A of 1 equals 70. The thing with a recursive formula is that you have to identify what the first term is. Okay, so let me check this next slide here. Yeah, okay, so I'm going to erase all this. Make sure you pause and have it down, and then I'm going to write out the general way that you need to think of this. Okay, so a recursive formula works this way. A of n is always going to be there, equals A of n minus 1 plus the common difference and then you'd say where A of 1 equals, and then this one is just the first term, so whatever that value is. This is how you write a recursive formula. You just fill in these things every time. So this is always there. This is always there. This you have to figure out is the common difference. This, the first term, is almost always given to you. Okay, so using that information, go ahead and give these two a try. The answer will be up in 3, 2, 1. All right, so here it is. This is the two answers for the recursive formulas. Now, you may notice on this last problem as well as this one here, it says, what is the value of the eighth term? And I didn't do that. You could go through writing out all of this like I did on that other example where A1 back here, A1 equals, whoops, too far. A1 equals 70, and then A2 is 70 plus 70, plus 7, and then A3, and so on. But really, you could just count these out. So 1, 2, 3. The fourth is 91, so that the fifth would be 98. The sixth would be 105, and so on. So over here, to find the eighth term, we could do the same thing. This is my fourth term. So if I just continue this pattern on to the eighth term, that's probably the easiest way to do this. So this one I'm adding 12. So this next one would be 71, 83, 95, 107. That's the eighth term on this one. This one, do the same thing. Just label these things out. I keep adding that, so 9.3, 9.8. 10.3, and 10.8. So the eighth term on this is 10.8. That part I don't think you should have an issue with. So let's see here. That's it for today. So make sure that you have the notes on that recursive formula stuff. Again, I'm breaking this section into two different parts. We'll start with this tomorrow, or the next day we'll be working on explicit formulas. Which isn't all that difficult, but again, you need to have really good notes on that. So make sure that you are preparing yourself for that.